This is a video for MEI Core Pure Mathematics, Calculus 2 Inverse Trig Functions, 2.1 Differentiating arc sine x. There are two main ways of writing the inverse sine function, and both arc sine x and sine to the minus 1 of x are commonly used, and you may have seen both used in textbooks. It's important to remember that sine to the minus 1 of x refers to the inverse sine function, and not the reciprocal 1 over sine x. We will use arc sine x throughout these presentations. This is a graph of arc sine x, and you can see that its range is between minus pi by 2 and plus pi by 2. Its domain is between minus 1 and 1 because sine can only take values between minus 1 and 1. The blue line is a tangent to the curve at this point here, and you can see that it has a positive gradient. Looking at the red curve, you can see that in fact the red curve always has a positive gradient, and we can write that dy by dx is always greater than or equal to 0. Okay, let's think about differentiating arc sine x then. I'm going to rewrite this to tell me that if y is equal to arc sine x, then that must be because sine y is equal to x. Now if I differentiate that implicitly, I'm going to get that cos y dy by dx is equal to 1. And if I rearrange that to get dy by dx on its own, I'm going to get that dy by dx is 1 over cos y. But I can rewrite cos y in terms of sine, and I can rewrite this expression then as 1 over the square root of 1 minus sine squared y. And I'm going to need a plus minus because I've just taken a square root here, so I need to consider both. But I also know that sine y is equal to x. So if I plug that into there, I'm going to get that this is 1 over the square root of 1 minus x squared. Again with a plus or minus. Now if you think back to the graph, we saw that dy by dx is always greater than or equal to 0. Which means that this thing here must always be positive, and so I can remove the negative square root. I'm only interested in positive values for dy by dx. So this gives me that my derivative d by dx of arc sine x is equal to 1 over the square root of 1 minus x squared. There's the working tidied up. So this is switching the function round, differentiating implicitly, rearranging that and working it back as a function of x. That's where we use the fact that dy by dx is always positive, and then I get my final result. So back to the graph of arc sine x. This is slightly different because I've drawn the tangent in at x equals 0. If we look at the algebra, when x equals 0, I should get a gradient of 1, and that blue line does indeed have a gradient of 1. Above 0 and below 0, the curve moves away from the blue line and gets steeper in both cases. So in fact, the gradient of arc sine x is always greater than or equal to 1. So not only is it always positive, but actually it's always greater than or equal to 1. Let's have a look at a more general derivative. I'm going to look at arc sine x over a, and again, just like last time, let's just rearrange this to tell me that sine y is equal to x over a, and then differentiate implicitly. So cos y dy by dx is equal to 1 over a, and then rearrange to get an expression for dy by dx. So dy by dx is equal to 1 over a cos y. Again, I can replace the cos y with root 1 minus sine squared y. And I don't need to worry about plus or minus because I know that dy by dx now is always positive. And again, from up here, I know that sine y is equal to x over a, and so this expression becomes 1 over a times the square root of 1 minus x over a all squared. Okay, a little bit of tidying up to do with that. So I'm going to get 1 over a times the square root of a squared minus x squared all over a squared. I can actually do a bit of cancelling down at the bottom here. This a squared, as it comes out through the square root, will just become an a, which will cancel off with that a there. And so this gives me 1 over the square root of a squared minus x squared. And therefore, finally, I can say my derivative over arc sine x over a is equal to 1 over the square root of a squared minus x squared. Again, that's been tidied up for you. Rearrange the function, implicit differentiation. Quite a bit of work to get this down to something in terms of x, but there's my final result. So in summary, differentiating arc sine x gives me 1 over root 1 minus x squared. Differentiating arc sine x over a gives me 1 over root a squared minus x squared. And it's this latter result that we will use when we look at integration in a later video. The next video in this sequence is 2.2, differentiating arc tan x.